system of homogeneous linear equations. So this is the system of homogeneous linear equations. A11 x1, A12 x2, A1n xn. What are A1, A11, A12, A1n? All are real numbers. Similarly, the second equation in this way, the mth equation. So this is the homogeneous system because all these constants are equal to 0. If one of them is non-zero, then the system is called non-homogeneous system. And this is homogeneous system. And we can write the homogeneous system in the matrix form as Ax is equal to 0. What is A? A is called coefficient matrix, A11, A12, A1n, A21, A22, A2n. In this way, AM1, AM2, AMN. And the constant, the matrix of unknowns or variables is x1, x2, xn, because the unknowns are x1, x2, xn, and is equal to 0, 0, 0 is the matrix of constant. Or okay, so this system, homogeneous system, can be written in the form of matrix form as Ax is equal to 0, where A is coefficient matrix, this matrix, X is this matrix, and 0 is this matrix. And where A is called the coefficient matrix, X is called the matrix of unknowns, and 0 is called 0 or null matrix or matrix of constant. And then augmented matrix is what? The combination of A and this 0. Similarly, in the non-homogeneous system, the system is of the form Ax is equal to B, and then augmented matrix is a combination of A and B. So here B is a 0 matrix, this null matrix, and therefore the combination of A and 0, that is this A oblique 0, this is called augmented matrix for this homogeneous system, and is what? A11, A12, A1n 0, because the column matrix is 0, the 0 matrix. Okay, A22, A22, A21, A22, A2n 0. In this way, the last row. So this is the combination of A, this matrix A, and 0 matrix. Then condition of consistency of homogeneous linear system. So when the system is consistent, and we know that when non-homogeneous system Ax is equal to B consistent, if the rank of A and rank of AB are equal, same here, that if when the system is consistent, this homogeneous system, if rank of A and rank of A 0, but rank of A 0 and rank of A both are always same, and so rank of A and rank of augmented matrix are always same in a homogeneous system, and so homogeneous system of equations is always consistent. That is there is no case that homogeneous system is inconsistent. So we know that what is the meaning of consistent and inconsistent. When we say the system is consistent, if system has at least one solution, and when we say the system is inconsistent, if system has no solution. And we know that for a non-homogeneous system, the system may or may not be consistent, but homogeneous system is always consistent, because rank of A and rank of A0, rank of A0 is always rank of A, and therefore, and we know that what is the trivial solution. If we take x1, x2, xn, all the values of these unknowns are equal to 0, then and if we substitute x1 as 0, x2 as 0, xn as 0 in the first equation, then we have the answer 0, LHS is 0 is equal to RHS. Similarly, if we substitute x1, x2, xn as 0 in the second equation, then we have the answer of LHS is 0 is equal to RHS, that is equation second satisfied in this way. If we substitute x1, x2, xn in the last equation, then this equation also satisfied. So this x1 is equal to 0, x2 is equal to 0, dash dash dash, xn is equal to 0 is the obvious solution of this system, or it's called trivial solution of this system. So every non-homogeneous system has at least one solution, that is trivial solution, and except that this solution, a trivial solution, the system may have another solution, that is the values of x1, x2, xn are not all 0, but that values of x1, x2, xn satisfies all the equations, and such a solution is called non-trivial solution. So there are only two cases that the system is always consistent, either system has trivial solution or the system has non-trivial solutions. Okay, so when the system has non-trivial solution, if rank of A and rank of A0 that is equal to number of unknowns in that system, that is rank of A and rank of A0 are always equal in the non-homogeneous system, but it is equal to number of unknowns, then the system has trivial solution, that is system has only one solution, and what is that? The values of all unknowns are equal to 0. And when the system has infinitely many solutions, or non-trivial solutions if rank of A is equal to rank of A0 is equal to R, suppose, and is strictly less than N, number of unknowns. Number of unknowns, what are the number of unknowns? X1, X2, Xn are called number of are unknowns, X1, X2, Xn. So if the rank of A and rank of A0 both are same and is strictly less than the number of unknowns, then the system has non-trivial solution. So this is the data. Homogeneous system is always consistent, Ax is equal to 0, and if rank of A is equal to N, that is number of unknowns, then the system has unique trivial solution. Trivial solution means what? All the values of all unknowns are equal to 0. That is x1 is 0, x2 is 0, dash xn is 0. And if the rank of A is strictly less than N, that is number of unknowns in that system, then system has non-trivial solutions or non-zero solutions. Okay, this is the zero solution. Trivial solution means the value of all unknowns are equal to 0 means zero solution, trivial solution. And the system has non-trivial solutions. Okay, in addition, trivial solution. Trivial solution is always solution of every homogeneous system. Trivial solution is always solution of every homogeneous system. But if rank of A is strictly less than number of unknowns, then the system has trivial solution as well as non-trivial solutions. Okay, that is the system has infinitely many solutions. So this is about the homogeneous system. Again, there are two methods: Gauss elimination method and Gauss-Jordan method, in order to solve the homogeneous system and non-homogeneous system. So in Gauss elimination method, convert the augmented matrix to row echelon form, and in the Gauss-Jordan method, we have to reduce the augmented matrix to reduced row echelon form. So this is the change. So these are the some examples. Important notes again is useful. These important results are useful for MCQ type questions. The matrix A and A dash have the same eigenvalue. So first we will see what is the eigenvalue, definition of eigenvalue. So the examples of homogeneous system and non-homogeneous system are already we have seen in the last 2-3 lectures. So this is the example of homogeneous system. So we have to solve the system means we have to write first the system in matrix form. This is the matrix of coefficient of x, y, z 2, 1, 3. In this x, y 2 and coefficient of z is 0. Then x coefficient in the third equation, x coefficient of x is 0. Coefficient of y is 1, coefficient of z is 1. X, y, z is the unknowns, and 0, 0, 0. Then consider the augmented matrix A0 or just A. Consider A in order to solve the homogeneous system. Consider augmented matrix A0. That is this matrix, and write the last column as 0, 0, 0, or take A and reduce the matrix to echelon form. If we have to solve this system, so we have to reduce this matrix to echelon form. So there it is 1. So we have to reduce this 2 to 0. So R2 minus 2R1, we have 0. And then R23. R23 means interchange the second and third rows in order to convert this minus 3 to 1. Then we have to reduce this minus 3 to 0. So R3 plus 3 R2 by using this 1. And so we have this, and then convert this 6 to 1. Then apply one more operation, transformation, that is 1 by 6 R3. Then we have the 0, 0, 1 as the last column. Okay, and rewrite the equations from this matrix. We have to rewrite the equation. So from this system we have this matrix. So we have to write the system from this matrix. So what is the first equation? X plus 2y is equal to 0 is the first equation. The second equation is y plus z is equal to 0. And the third equation is 6z, or if you convert this to 1, then 1z, that is z is equal to 0. So if we substitute z is equal to 0 in above equation, then we have y is equal to 0. And if we substitute the y and z as 0 in the above equation, we have x as 0. So x is equal to 0, y is equal to 0, and z is equal to 0 is the solution of this system. And that is the zero solution, or is the trivial solution, obvious solution of this system. Okay, and if we denote the rank of A, then rank of A is what? 3, because this is the echelon form of this matrix A, and this matrix contains 3 non-zero rows, and so rank of A is 3, and it is equal to number of unknowns, because number of unknowns in the system are 3, and so system has only one solution, that is the trivial solution. X is equal to 0, y is equal to 0, and z is equal to 0. Similarly, this is the problem on the homogeneous system. So we have to write the system in the matrix form. This is the matrix form. The unknowns are u, x, y, z, u, x, y, z. So, and then consider the matrix of coefficient, that is a or a0, right? The last column as 0, 0, 0. And we have to reduce this matrix to echelon form. So we have to reduce this first 0 to 1. So R12 as the operation. Then we have 1. Then we have to reduce this 3 element to 0. So R2 minus 2 R1, R4 plus R2 minus 2 R1, and R4 plus 2 R1. So we have this matrix. Then we have to reduce this 2 to 1. So 1 half R2 is the operation. We have this. Then we have to reduce this 3 and 1 are equal to 0. So R3 minus 3 R1, R2 not R1, and R4 minus R2. So we have this matrix. Okay, and then we have to reduce after this we have to reduce this element to 1, but it is 0, so it cannot be reduced to 1. So we have to reduce this element to 1, but both are 0. So shift this, we have to reduce this element to 1. It is already 1. Then we have to reduce this minus 10 to 0. So R4 plus 10 R3. So this is an echelon form, or it's called row echelon form. It is not reduced row echelon form. It is just row echelon form or echelon form. And what is the rank of A now? So this matrix contains 3 non-zero rows only. The last row is 0. So rank of A is 3, and the number of unknowns are 4. So rank of A is strictly less than number of unknowns, and therefore this system has infinitely many solutions, trivial as well as non-trivial solutions. So how we can find the solution of the system? So rewrite the equations. So what are the equations? We have to write the equations from this matrix. So U minus y plus 3z is equal to 0. Plus 3z, not minus 3z, right here, plus 3z is equal to 0. Okay, okay, it is minus 3, here is minus 3, so write here minus 3 and here write minus 3. So it is u minus y, u x, the coefficient of x is 0, so minus y minus 3z is equal to 0. Then x plus y plus 2z is equal to 0, and the last equation is z is equal to 0. So there are now, if you observe, there are 3 equations, 1, 2 and 3, but unknowns are 4, u, x, y, z. Unknowns are 4, so we have to assign one unknown. So we have the value of z, so don't assign z, we have to assign, suppose y. So y is t, suppose y is t. So then from the equation substitute z as 0 and y as t, we have x is minus t from this equation, and substitute the values of y and z, y as minus t, y as t, then z as 0. So we have u as plus t, and therefore the solution is what? U is equal to t, x is equal to minus t, y is equal to t, and z is equal to 0. And if you where t is what? T is any real number. So we assume y as t or r or s. Take any notation. What is t? T is any real number. So if you take t as 1, then we have the solution 1 minus 1, 1, 0. If we substitute t as 2, then we have 2 minus 2, 2, 0. So we have the infinitely many solutions. If we substitute t as 0, then we have u is 0, x is 0, y is 0, z is 0. So that is trivial solution. Obviously, every homogeneous system has trivial solution as well as some system has non-trivial solution. So this system has infinitely many solutions. This system has trivial as well as non-trivial solutions. Okay, 0 as well as non-zero solution. Similarly, this is the system. We have to reduce the system to matrix form. So this is the matrix form. There are 2 rows in this coefficient matrix, and u, x, y, z as the matrix of unknown. Then convert this matrix, coefficient of matrix, to echelon form. So this is echelon form, and then rewrite the equation. So what is the rank of A? Rank of the matrix A is 2, because there are 2 non-zero rows, and obviously is strictly less than number of unknowns. Number of unknowns are 4. So rewrite the equation. So after rewriting, u minus x minus z is equal to 0, and then x plus 1 by 4y plus z is equal to 0. So if you observe, there are 2 equations and 4 unknowns. So we have to assign 2 unknowns. So assign, suppose z as t and y as 4s, because 1 by 4 is there. So to eliminate fractions, to avoid fractions, we have to take y as 4s. Instead of y as 4s, we can assume y as s. So Z and Y are these. It is our assign unknowns, because there are two equations and four unknowns, so assign two unknowns. So take Z as t and Y as 4s or just s, and then find x, value of x from this, and value of u from this. So this u is equal to minus s, x is equal to minus s minus t, y is equal to 4s, and z is equal to t, where s and t are any real numbers. This is the solution. Obviously, if you take s and t both are 0, then we have the values of all unknowns, that is u is 0, x is 0, y is 0, z is 0. So obviously 0 solution is the solution of the every homogeneous system, as well as this system has non-trivial solution, non-zero solution. Similarly, observe this problem again. This system has infinitely many solutions. Next topic, we have to discuss the next topic, that is the eigenvalues and eigenvectors. So this is all about the homogeneous system, non-homogeneous system. Now we have to define eigenvalues and eigenvectors. So already, what is the definition of eigenvalue? Already we have seen in the first lecture that what is the definition of eigenvalue. If A is a square matrix, then and x is belongs to Rn is the column vector, then Ax is equal to lambda x. If you have Ax is equal to lambda x, that is if lambda and x satisfies this equation, Ax is equal to lambda x, then lambda is called eigenvalue of A, and x is called the eigenvector of A. So x is called the eigenvector of A corresponding to eigenvalue lambda. Okay, and how we can find, this is the definition, and how we can find the eigenvalue. So in order to find eigenvalue, we have to find the characteristic equation first. What is the characteristic equation? Determinant of lambda I minus A is equal to 0 is called the characteristic equation of A. Okay, so first find lambda I minus A, then determinant of lambda I minus A, and then determinant of lambda I minus A is equal to 0 is the characteristic equation. Okay, so instead of determinant of lambda I minus A, we can also take A minus lambda I. Either write A minus lambda I or lambda I minus A, one and the same. So find the determinant of lambda I minus A or lambda determinant of A minus lambda I. Okay, and is equal to 0. This is the characteristic equation of A, and the roots of the characteristic equation are the eigenvalues of that matrix. Okay, so already these problems are discussed in the previous lecture. So we have to find the eigenvalues and eigenvectors. More problems on. So and more problems on the eigenvalues and eigenvectors. So how can find the eigenvectors? Eigenvector of the matrix. So how we can find the eigenvector? Ax is equal to lambda x. If Ax is equal to lambda x, then x is called the eigenvector of A corresponding to lambda j. So this is the definition of eigenvectors. So in order to find the eigenvector, solve the equation in order to find the eigenvector, we have to solve the equation A minus lambda I x is equal to 0. A minus lambda I x is equal to 0. So we have to solve this equation. A minus lambda I x or lambda I minus A x is equal to 0. So in order to find the eigenvectors, we have to solve this equation. We have to find the solution of the equation A minus lambda I x is equal to 0. So remember this. This is the procedure to obtain the eigenvectors. That is, we have to solve the equation A minus lambda I capital X is equal to 0 or lambda I minus A x is equal to 0 in order to find the eigenvectors corresponding to eigenvalue lambda. Okay, so some important results. So these are important results for MCQ type questions. The question is, the first remark is, the first result is the matrices A and A dash. What is A dash? A dash is the transpose of the matrix A. It is denoted by A dash or A raised to small t or A raised to capital T have the same eigenvalues. That is the eigenvalue of A and eigenvalues of A and eigenvalues of A dash both are same. So this is A matrix, and how we can write its transpose A dash. That is, write first row as a first column, A11, A12, A1n. Write second row as a second column. Write last row as a last column. So this is the A dash, and the A and A dash both have the same eigenvalues. So this is the proof uh, that A and A dash have the same eigenvalues. We will as a as far as the MCQ type questions, we only remember that A and A dash have the same eigenvalues. No need of this proof. Then if A is a non-singular matrix, then eigenvalues of A raised to minus 1 means A inverse are the reciprocals of the eigenvalues of A. So this theorem is also important for MCQ type questions, this result. So if A is a non-singular matrix, what happens if A is non-singular matrix, then A inverse exists. And if then what are the eigenvalues of A inverse? The reciprocals of the eigenvalues of A. Suppose A has the eigenvalues 2, 3, 4. Suppose A has the eigenvalues 2, 3, 4. And then what are the eigenvalues of A inverse? That are 1 by 2, 1 by 3, 1 by 4. This is the meaning of this theorem. Suppose A has the eigenvalues 2 and 5. Then what are the eigenvalues of A raised to minus 1? That is A inverse. The eigenvalues of A inverse are 1 by 2 and 1 by 5. Okay. So this is the meaning of this theorem. If A is non-singular matrix, then the eigenvalues of A inverse are the reciprocals of the eigenvalues of A. So this is the proof. So again, this is important. That is, if the MCQ type question is what? Suppose the eigenvalues of A are given. Suppose the eigenvalues of A are 1, 2, 3. Then what are the eigenvalues of A inverse? The eigenvalues of A inverse are again 1 by 1 means 1, 1 by 2, 1 by 3. 1, 1 by 2, 1 by 3 are the eigenvalues of A inverse. If the eigenvalues of A are 1, 2, 3, then what are the eigenvalues of A dash? Again 1, 2, 3, because A and A dash have the same eigenvalues. Similarly, this is the second result. Then if the eigenvalues of triangular matrix, that is, there are two types, upper triangular matrix and lower triangular matrix. So are the just diagonal elements of that matrix. So eigenvalues of triangular matrix, suppose this is the matrix, this is upper triangular matrix. So when we say the matrix is upper triangular matrix, if the diagonal elements below the elements below the diagonals are all 0, all the elements below the diagonals are 0. For example, this is the diagonal and all the elements below the diagonal of the matrix are 0. So this is the upper triangular matrix. And if all the elements above the diagonals are 0, then matrix is called a lower triangular matrix. And if the matrix, or if all the elements above the diagonal and below the diagonals are 0, then it's called diagonal matrix. Okay, upper triangular matrix, lower triangular matrix. So the eigenvalues of the triangular matrix are just the diagonal elements of that matrix. No need to find the eigenvalues by using procedure that determinant of lambda I minus a is equal to 0 and then the roots of that equation. Just the the diagonal elements are the eigenvalues of that matrix. So this is the upper triangular matrix. So A11, A12, A23, A33, ANN. These elements are the eigenvalues of this matrix. So if the matrix is upper triangular, lower triangular. Obviously, if the matrix is the diagonal matrix, that is suppose 1. Obviously, if you take I3, I3 means the identity matrix or unit matrix of order 3. That is 1, 0, 0, 0, 1, 0, 0, 0, 1. So what are the eigenvalues of this matrix? This matrix is upper triangular, lower triangular means diagonal matrix actually. So the eigenvalues of this unit matrix are 1, 1, 1. Okay, identity matrix. I3. Eigenvalues of I2 are 1, 1. Eigenvalues of I4. I4 means the unit matrix of order 4 by 4. 1 0 0 0 0 1 0 0 0 0 1 0 and 0 0 0 1. So this is the identity matrix I4. And what are the eigenvalues of this matrix? 1 1 1 1, right? 1 1 1 4 times. So this is about the next result. If k is a positive integer, if lambda is eigenvalue of a and x is the corresponding eigenvector, then lambda raised to k is the eigenvalue of a raised to k and x is the corresponding eigenvector. There is no change in the eigenvector. But if lambda is eigenvalue of a, then lambda raised to k is the eigenvalue of a raised to k. Okay, so this is again the important theorem. K is positive integer. Suppose that is we are given the matrix A and the eigenvalues of A are suppose 2 uh, uh, 3 1 2 3. Okay, suppose A is of order 3 by 3 and A has the eigenvalues 1 2 3. Then if the question is find the eigenvalues of A raised to 5. So what are the eigenvalues of A raised to 5? Are 1 raised to 5, comma 2 raised to 5, comma 3 raised to 5. So these are the eigenvalues of A raised to 5. So if lambda is eigenvalue of A, then lambda raised to k is eigenvalue of A raised to k. So this is again important result for MCQ type questions. Suppose we are given the matrix A, the eigenvalues of A are 2 3 4, and the question is find the eigenvalues of A raised to 5 or A raised to 6, A raised to 6. Then what are the eigenvalues of A raised to 6, 2 raised to 6, 3 raised to 6, 4 raised to 6. These are the eigenvalues of A raised to 6. So, and x is the corresponding eigenvector. So, in order to find the eigenvectors, we have to solve the equation Ax is equal to 0. So, we will see the problems of eigenvalues and eigenvectors. We'll see the problems of eigenvalues and eigenvectors. So the question is find the eigenvalues and eigenvectors of this matrix. So first we have to find the eigenvalues of this matrix. How we can find eigenvalues? That we know that we have to find the first characteristic equation. What is the characteristic equation of the matrix A? Determinant, right? Determinant like this mod, right? Mod A minus lambda I, determinant of A minus lambda I or determinant of lambda I minus A is equal to 0. This is the characteristic equation. Determinant of A minus lambda I or lambda I minus A. Take a new. So first find A minus lambda I. First find A minus lambda I. So A is this minus lambda I means 1 0 0 1. So multiply by this lambda to each element. So we have the matrix lambda 0 0 lambda, and then subtraction is 5 minus lambda, then 4 minus 0 means 4, then 1 minus 0 is 1, and 2 minus lambda, and its determinant is 5 minus lambda into 2 minus lambda minus 4, that is lambda square minus 7 lambda plus 6. This is what determinant of A minus lambda I. And if you have to find the characteristic polynomial, then characteristic polynomial is what? Is the actually determinant of lambda I minus A. So it is minus 6 minus plus 7 lambda minus lambda square. This is the characteristic polynomial. So this is after changing this sign of this, we have the characteristic polynomial. But there is no need to change the sign, because the characteristic equation of the matrix A is what? Determinant of A minus lambda I is equal to 0, or right, determinant of lambda I minus A is equal to 0. When I just said, so this is equal to 0. This is the characteristic equation. Actually, what is the multiplication of these two? Multiplication of these two is what? 10 minus 7 lambda plus lambda square. Okay, and so we have this as the then characteristic equation of the matrix A is what? Determinant, right? The word in word det in bracket A minus lambda I or lambda I minus A is equal to 0. This is the characteristic equation. That is lambda square minus 7 lambda plus 6 is equal to 0. And what are the roots? Factorize this lambda minus 1 into lambda minus 6 as the factorization. So lambda is equal to 1 and 6. So 1 and 6 are the eigenvalues of the matrix A. Now, in order to find the eigenvector, we have to solve this equation. A minus lambda x is equal to 0. So we will see the remaining part of this example in the next lecture.